Welcome back, picture shufflers. All right, on to day 2. So for day 2, we're going to continue with our game. Remember last time when we left off, we had a game that had a fully functioning image and a fully functioning is game over method, but it wasn't yet a very good puzzle because there was nothing for the user to do or interact with. So that's what we need to add in today. In order to add that in, we need there to be an empty space in this picture so that the user has a space to move. Now, you can choose whichever corner of your picture you want or side of your picture that you want, but my suggestion is likely to pick a corner where there isn't a lot to the image so that you're not losing a bunch from the image. In my example, when I was making it, my corner that was the most boring was that top right corner. So I chose to remove that piece and let that piece be empty for me. But you can really do this with any piece that you would like. So all that you are going to do is after you've done this whole for loop to set the values within your grid, you're going to go back into your code. And what you're going to do is you're going to set that one random location to be empty. So you're going to go to the grid of, I'm just going to call it special R, special C. And what I mean by that is whatever special row and special column you decide is going to be the one that's empty, and we're going to set that one equal to 0. So that'll show up as gray rather than showing up as the image. Run it really quickly, make sure you're happy with and okay with that corner being missing from your image because that's the one that's going to be gone when you make the puzzle. But this is now what's giving us the space to be able to play the game. So make sure you like it. If you don't, pick a different one. I would suggest using a corner. Usually that has the least information that you're going to lose, but up to you. Okay, now that you've done this, a little bit needs to change about our is game over method. Because remember, I'm going to go check the grid and let's pretend that my special row, special column is that top right corner. I'm going to go check the grid. And when I get to that top right corner, I'm expecting to see the number 3 according to is game over, but I'm expecting to see the number 0 according to what I've coded right here in blue. So inside of my check, I need to do one thing for my special row, special column. So whatever that's going to be for you, we have to do a special check. And that special check is going to be us seeing if we're at that within our looping system first. So if the row that I'm at, that R value, is equal to the special row, and the column that I'm at is equal to that special column, well, then that means I don't want to do the regular check of if it's equal to the counter. That means I want to do a special check. Get it? It's the special one. And then I'm going to close it, and then I'm going to turn this into an else if right here. If. Okay, so I'm going to undo that being highlighted and undo that being in black, so now it's different. So what I've added in is like an if block, and so therefore I'm making the other part an else to that if. Okay, so if I'm in the situation of I've got that special row and special column as I'm looping over, I am not expecting to see the counter variable. What I am expecting to see is 0. If I get to that special location and it's not 0, you aren't empty at the space that you decided was going to be empty, which means that we're not yet done solving the puzzle. So again, I'm going to do kind of a backwards check. So if the grid of that special row, if the grid at that row and column, because we are still using RC and that's what we're looping over here, is not equal to 0, even though we expect it to be according to this top line, then that means we're not done solving. So we should go ahead and return false. And then keep going, keep looping. Sorry, we should return false, which means we don't keep looping, which means our game is not over, we should keep playing. And this is the extra check that we needed to add into our is game over to be sure that we do account for the new empty space. And remember, we need this empty space in order to be able to play this game. We have to have an empty slot to be able to move into. And from here, then all we need to do is make the move method. So we have a one-click move method that I'm going to use when we play this game, simply because there isn't really a question of where you want to put that piece. When you click on a piece, you're saying, I want to slide that piece into the empty position. So we don't really need this game to be 2-click. We can go ahead and leave it as 1-click. So when you have our move method, we have two inputs. We have an int row and we have an int column to get input into this method. And what we want to do is, first and foremost, always when we make this our games, is we want to check that our click is in fact inside of the grid. So we're going to do an if row call is in grid. So you have an is in grid method that you've written for previous code. Go steal that one or write it again. If it's within the grid, then we're going to do some stuff. So I'm going to leave this blank for a second, but we're going to do some stuff here eventually. If it's not within the grid, we immediately want the user to know you can't click there. You can't move a piece that's not within the grid. So we would print out something like must click within the grid. And because this move method has a return statement to it, we'll go ahead and return false. That is not a valid move. Sorry, try again, return false there. I'm actually gonna, for the sake of clean coding, move all of those in. Okay. So then, if we are in a situation where we did in fact click within the grid, remember, not every piece within the grid can always move. When you're doing this kind of puzzle sliding around, only pieces that are around that empty position are in fact allowed to move. So we need to check is once I've clicked somewhere, like, is that piece actually able to move into the empty space? Is that empty space within the plus around it? And what I mean by that is it up one, is it down one, is it to the left one, or to the right one? Kind of like what we did when we checked turn out the lights. So only those 4 neighboring positions. We can't move diagonally here. But if the empty position is either vertically 1 up or 1 down, or horizontally 1 left, 1 right, then we can go ahead and move that piece. So the next thing that we want to do is we want to check to see, well, where's the empty piece? Is that empty piece in fact near us? And so we could loop over the whole grid to figure out where the empty piece is and then check that compared to the row and column. We could. But we could also just go check those 4 neighbors. So what I want to do is I want to check if the grid position, and I'm going to say of the 4 neighbors, because we know how to access those 4 neighbors of the row +1, column +1 kind of stuff, is equal to 0. Now you can't do all 4 neighbors at once. You're going to have to do them one at a time, but you know what I mean when I say go get the grid position of one of the 4 neighbors. If that's equal to 0, then that means we can continue making a valid move. So then we'll make the move inside here. Oof, with tons of typos. However, if we get to a situation where, oops, I could have just stayed right there. I've checked all of my neighbors and they aren't in fact 0, meaning none of my 4 neighbors are empty, then that means I can't actually move. You can only move pieces adjacent to the empty slot or something like that, so that your code knows what's going wrong, and then we'll return false. Oof, here we go. Coding on a Google Doc. Okay, and then we can delete all of this extra space. We don't need any of that. So now what's left is the idea of actually making a move. And what it means to make a move for this game is that those 2 picture positions swap with one another. So what was previously in the neighbor's position is going to go into your location, and what was previously in your location is going to go into the neighbor's. They are going to switch positions, which seems pretty easy, and it is, but we have one little caveat to it. The way that I want to do that is I'm going to go ahead and say switch values, and I'm going to make that a method where I pass in the row and column of where I've clicked, and then I pass in whatever neighbor row and neighbor column is the empty one. Now you may be thinking to yourself in this moment, Miss Glenn, it's probably easier than that. And it actually might be, but it turns out that this switch value method becomes helpful to us later on. So I'm gonna go ahead and make it now, and you'll see its get it? You'll see its use a little bit later on, maybe in day 3. So I'm gonna switch the value. Now remember, this is gonna show up in bright red for you when you first do it, because this is a method that you haven't yet written. So then let's go back and let's write out that method. So what does it mean to switch values? Well, that means I want to take the first value and set it to be the seconds, and I want to take the seconds and set it to be the first. So I'm going to make a public void switch value method that should take in 4 inputs. I'm going to call it row 1, column 1, and yep, that is a 1. And then row 2, column 2. Okay, and that's going to be my switch value method. So I'm going to put this in red so that we see that these two things go together. Okay, so what I'm trying to do is I want to take grid position of row 1, column 1, oops, and I want to set it equal to the grid position of row 2, column 2. So everything's fine and dandy if we go ahead and do that. But now from here, when I want to do that same thing backwards, and I say, okay, go to the grid position at row 2, column 2, and now I want to set it to be what was here at row 1, column 1, I've lost it. I've already reset row 1, column 1, so I've lost what that value was to begin with. I don't remember what it was. The computer's already deleted it and replaced it with what we said to. So the one thing that you're going to have to add into this method besides these 2 lines is a placeholder variable. So I just created an integer that I called placeholder, and its job is to hold this value so that I can reset it one and then reset the other without losing that information. So it's going to go get the value of that row 1, column 1, and it's going to hold on to that information. So after I change the value at row 1, column 1, I still know what the original value was. So then I can set row 2, column 2 equal to that placeholder. Now, all of this right now, I've been operating under the assumption that these neighbor positions actually even exist. And that's not for sure a true statement. So what I want to do before, way back, is I actually want to go back and I want to check to be sure that my neighbor positions are within the grid. What if I move to a column? I don't actually have all 4 neighbors to go check. So we're going to do one quick check of if, I'm going to just say like 4 neighbors in grid. And if one of them is equal to 0, then we should call the switch value method. So by the time I'm calling the switch value method, I do already know, in fact, that these 4 neighbors are within the grid. But because I'm going to be accessing random locations within a grid that are being passed into me for safety of my programming, in the sense of when I want to maybe use this switch value method later on, I should probably check these 2 locations again inside of this method. So I'm again going to do an if row 1, column 1 in grid and row 2, column 2 in grid first before I go change all of their values. Reason being, what if I call this method with a typo in it or anything else, or I call this method somewhere where I haven't checked an is in grid beforehand? I don't want to crash my program. So in order to prevent my program from crashing, we're just going to be doubly careful and check that location. All right, and then with all of this, at this point, you should see tiles that you can move all around your screen. Your game will still start with you winning, and you'll have to shuffle and then unshuffle, but at least you are to a point now where you can shuffle, you can move the pieces around, and hopefully get yourself back to be able to then win the game. And next class, we'll talk about how to set up that board so that it's tricky without you having to shuffle the board yourself.